Alright, P and Q. A particle of mass particle P of mass 3m and a particle Q, okay, are at rest on a rough horizontal surface. Okay, this is a rough horizontal surface, so we're going to be worried about friction here, and we can see that there's already a question about coefficient of friction. So we're going to need the normal reaction, because we know that the max friction is equal to mu times the normal reaction. So what I'm going to do is just label the normal reaction here, because we know that we're going to be needing it, so why not? Just to make sure we don't miss it. I mean, of course we won't, but you know. And if you have a question, like a very silly question, but I condone it, that's not a problem. Why is it 3 mg? Well, it's not moving in the vertical direction, is it? If it's not moving in the vertical direction, that just implies that it's not accelerating in the vertical direction, which means it has a zero acceleration, which means that in the vertical direction there is no resultant force as well, due to Newton's second law. So if there is no resultant force, that must mean that whatever force is acting on this particle upwards is equal to whatever force is acting on the ball downwards. And downwards we know there's the weight. Therefore, the reaction force exerted on the ball by the ground in the upwards direction is going to be the same as the weight. That's how we get it. That's the whole logic. Now, the distance between P and Q is 1.4 meters, and an impulse of magnitude lambda Newton seconds is now applied to P in the direction of PQ. Okay, so we are now exerting an impulse. Okay, like in this direction, towards Q. And that's lambda Newton seconds. Okay? Immediately after the impulse is applied, the speed of P is 5 meters per second. So the immediate velocity, immediately after the impulse is applied, the speed is 5. So like initially it was at rest. So you can already kind of get a vibe of this being from chapter 6. I think chapter 6 is momentum. So what this essentially means is that initially this is at rest. So you have 0 meters per second here. And this is just a hybrid question with coefficient of friction, chapter 5, I think, or even 7, I don't know, along with momentum. I love M1. Okay, we have 0 meters per second, and then we have 3m, and then this is the before, and this is the after. So you're getting an impulse of lambda, and then after getting that impulse, you're not moving at 5 meters per second. And I'm saying now at that instant, right? Like after it just got the impulse, it is only immediately after the impulse had been applied that the speed is 5 meters per second. Going down this same path, you're not going to be at 5 meters per second. Why? Because, well, you're on a rough horizontal surface. Your speed is going to decrease. So, yeah, that is that. Now, we know the formula. Impulse is equal to m times v minus u. Okay, impulse is acting towards the right. So what we're going to do is solve this by taking the right side as positive. If you do that, we're going to have lambda is equal to mass. The mass is 3m times final velocity is 5. This is in the same direction. So we're going to have plus 5 minus initial velocity is just 0. So we have 15m. 15m is our answer. There you go. That's just so easy. Immediately before P collides with Q, the speed of P is 2.5 meters per second. Immediately before P collides with Q, the speed of P is 2.5 meters per second. Okay, so like you see how there was how P was moving with 5 meters per second speed, and then it decelerated because, well, we're on a rough horizontal ground. It decelerated all the way to 2.5 meters per second just before it hit Q. Okay, so it essentially hits Q with the speed 2.5 meters per second. So you have P here with mass 3m, and it hits it with 2.5 meters per second. All right, now the coefficient of friction between P and the surface is mu. Find the value of mu. Okay, so we're essentially not worried what happens to Q. We're not worried about that. We're just worried about P and the coefficient of friction between it and the surface. Okay, how do we do that? Well, since we have the initial and final velocities. What are they? Well, the final is 2.5 and the initial is 0. No, it's not. The initial is 5. That is when we actually start moving, so that's going to be our initial velocity for now. That's going to be our initial velocity, and that's the final velocity. This is v, and this is u. And we're going to have to work out the acceleration, or the deceleration in this case, but you know what I mean. Acceleration is going to come out negative. Let's do that first. For b, let's find out the acceleration. That's going to be v. Okay, not v minus u by t, because we don't actually have t, but what we have is the distance. It travels 1.4 meters, and it decelerates from 5 meters per second to 2.5 meters per second. So we have u and v and s. Now, which equation has all of these variables? Is the one with v squared is equal to u squared plus 2as, right? So if we make a the subject in that equation, we actually end up with v squared minus u squared divided by 2s. This just, you know, I've just happened to have memorized that because the amount of times I've done these questions, this is just in my head. You can just start off with v squared is equal to u squared plus 2as. All right, no need to sweat it. Acceleration, we can find this out. V is 2.5 squared minus 5 squared divided by 2 times the distance is 1.4. We're going to be getting 2.4 minus 5 squared divided by 2 times 1.4. We're going to get minus, okay, in the calculator it shows minus 6.6964 blah blah blah. I'm not going to take the rounded off value, okay? Always mid calculation, mid problem solving, you're going to take the exact value, or at least try to. If you don't get an exact value, well, what's there to do? You're just going to take as many decimal places as you can, just so that you ensure that you get the most accurate answer in the end. So it also shows that this comes out to be minus 375 over 56, the same thing, meters per second squared. This is the acceleration. And now we can actually use Newton's second law. Resultant force is equal to ma. And if you actually resolve for the particle p in this direction towards pq, then what do we have? What forces are acting on p? What are the forces? And remember, I'm only concerned about the forces that are acting in the horizontal direction, not other forces, not the weight or the reaction force. Okay? So in the horizontal direction, we have the friction only, right? We're moving towards the right, and since this is a rough horizontal surface, we're gonna have friction opposing the motion. So yeah, that's just the only force acting on P. There are no other force. Yes, there is a force, but that's just initially, right? That is the force that we are actually applying, that comes from this impulse. Well, impulse is not exactly force, but it comes from force, right? Impulse is F times T. And there's force. And because of that force, an impulse is being created. Okay, which is why it starts to move. Alright, we got that. But that force doesn't stay through the whole journey, right? What we're really concerned about, just that one friction. Now, what is friction here? Friction is just going to be max friction. Why is it max? Why is it not just some frictional force that is less than the max friction? Well, this particle is already moving. That must mean that it already has surpassed the maximum friction, or else it wouldn't have even moved at the first place. Now, what is Fmax? Fmax is mu times the reaction force. We already did find out the reaction force. That's 3 mg. So we're gonna have minus 3 mg mu. And why minus? Well, we're resolving in the horizontal direction, that's fine, but specifically we're resolving in the positive x-axis. We're just taking the right side as positive here, essentially. That's what we're doing. And since friction is in the opposite direction towards the left, we're gonna have to put a minus. Force is a vector quantity. Keep check of the signs, okay? And very important. So you have minus 3 mg mu. That is equal to, because no other forces, so that's just equal to mass times acceleration. Mass is 3m. And acceleration, which is actually just found out, minus 375 by 56. There we go. So So minus and minus, they just cancel. 3 and 3 cancel. M and M cancel. And mu is just going to be 375 divided by 56g. Yeah, that's it. Now, of course, we're not going to keep it like that. It's best if we just give mu to 3 significant figures. So we're going to put this into the calculator. 56 and 9.8. That gives us 0.683. That should be our answer. Okay, next question. Immediately after P collides with Q, the speed... Okay, now we're back to momentum. Alright, I love this question. I love M1. Okay, immediately after P collides with Q, the speed of Q is 2.1 meters per second. What do we do now? We know that they're colliding here. So we can actually just use this diagram here. This is the before, and this is the after. So after the collision... Oh my god, this just became a square. Don't mind that. This is Q and this is 3m, this is m. I just like to write the masses down again. Okay, and immediately after P collides with Q, the speed of Q is 2.1 meters per second. 2.1 meters per second. They're asking us to find out the speed of P. Let's call that V, okay? This is just simple momentum. We can just use the conservation of that law, CLM, conservation of linear momentum. If we do that, we're gonna have, well, okay, so initially we have what? 3m times 2.5, mass times velocity, and Q was at rest, so Q has no momentum. That's just it for the total initial momentum. And now the total final momentum, we have, 3mv. Oh, by the way, we don't actually know that if P actually keeps moving towards the right, okay? It may have rebounded and started moving towards the left. But what we do is we just like to take one direction. We assume that P is going to move towards the right here. You could also assume that it's moving towards the left. Doesn't matter. The difference is that, let's say in reality it actually did rebound, but while we're solving this, we just took this direction as the positive side. So when we would actually solve for V, we would actually find a value that is negative, okay? And that negative includes, sorry, what am I saying? That negative sign indicates that this velocity is actually in the opposite direction, opposite to what we had assumed, okay? That's the difference. So keep that in your mind. We have 3mv right here, and then we have plus 2.1m. There we go. So all these m's just cancel out, okay? Very simple. And v is actually just equal to 3 times 2.5 minus 2.1 divided by 3. You just solve it however you want. Okay, 3.25 minus 2.1 divided by 3. That's going to be 1.8 meters per second. Okay, now you notice that this is actually just plus 1.8. So there is no change in the direction of P's movement. The P is just moving in the same direction, but just with speed 1.8. Oh, also keep in mind, it's not always going to be 1.8. It's just after the collision. Right after the collision, it's moving with 1.8 meters per second, but then of course it's going to start losing that speed. Since you're on a rough surface, right? Of course you're going to lose speed.